Welcome to next lecture 24, lecture number 24, which is on very high resolution remote sensing data. So, in this lecture we will explain what are those satellites from where we can get the resolution ranging from 5 meter to sub-meter resolution, and what are the advantages or utility of those images. Let us begin that. So, when we are defining the spatial resolution nowadays, poor resolution, medium resolution, high resolution and very high resolution. Earlier when these very high resolution satellite data was not available, in fact the high resolution were called as very high resolution satellite. But since very high has come now, we get less than 5 meter resolution. So, now we have a separate category which is called very high resolution. So, there is no clear cut demarcation as far as we categorize the satellites as per their resolution. There is no clear cut demarcation. As the technology changes and we get better and better resolution satellite data, we change our boundary line. So, this is what is happening is, but generally speaking, when I am talking of low resolution systems, I am talking of where the pixel size is more than 1 kilometer. But when I am talking of a very high resolution system, mainly my focus is less than 5 meter pixel size. So, any satellite sensor which is providing me data less than 5 meter in size, it is coming under the very high resolution system. So, you have seen that some of our Indian remote sensing satellites, some spot satellites are also falling under this category now, because the data is available at less than 5 meter resolution. But there are satellites which provide GOI, Iconos, QuickBird, they are providing us multispectral data also at very high resolution. So, if we look at the area, as we move from low resolution to a very high resolution, we are losing the area covered. We had a very wide area covered at a low resolution, but we have a small area, very narrow area covered. So, we have to see that particular aspect also when we are making a selection of the satellite image, at how many scenes are required to be analyzed in order to cover my area. So, this particular slide shows that the different satellites is giving me different coverage, one scene. So, this is Landsat 7, the black one is Landsat 7, which is covering approximately 185 kilometer by 170 kilometer on the ground at 30 meter spatial resolution. But when I am talking of the red box here, which is 145 kilometer by 145 kilometer, it is Indian remote sensing satellite data at 20 meter resolution. Spot French satellite, which is the pink box here, it is covering 60 kilometer by 60 kilometer one scene. QuickBird data is 16 kilometer by 16 kilometer at 2.5 meter resolution. But in other satellites like OrbView satellites, which is a purple color here, or the yellow color Iconos data, it is covering 8 kilometer by 8 kilometer by OrbView and 11 kilometer by 11 kilometer by the Iconos data. So, area covered becomes smaller and smaller as we are talking about the higher resolution data. So, let us see some of the very high resolution satellite data which are available to us commercially. We can procure the images from these satellites. So, QuickBird launching was in 1999, Iconos again in 1999, OrbView in 1999, OrbView 4 for example 2000, P 1999, Spot 5 2001. So, it is not a complete list, it is just the exemplary list that there are satellites data became available to us from these satellites at very high resolution from 1999 onwards. And the width, swath width was comparatively less. So, you can see that swath width was ranging from 60 kilometer Spot 5, 22 kilometer for quick bird, and then it became smaller and smaller, like 13.5, 11 or 8 from the other satellites. Resolution wise also, so we have reached from 5 meter which we are getting from the spot data to 0.5 meter or 0.6 meter from the quick bird data. So, very fine resolution is there, we can see those detailed information from this satellite data. So, these are some of these satellites are launched by private entrepreneur. So, this was another unique feature that so far the satellites, the polar satellite which we were talking about, they are launched by some government agency of that particular country. But here the entrepreneur came, the commercial companies came into the market, and they launched these, launched the satellites and tried their luck in this field, and they were quite successful, because this satellite data has some unique characteristics as compared to what was available. Let us take one by one, like this is a Iconos satellite. So, you can see the image of the Iconos satellite. This was a satellite which was developed by a company called Space Imaging, and it was launched in the year 1999. This is again a polar satellite, a sun synchronous satellite, but it is actually launched at a slightly lower altitude. It was covering around equator around the morning time, it was imaging that particular area, and ground track repeats every 11 days. So, every 11 days, 12th day we get the repeat image of the area. So, this can collect the data up to 35-degree angle along and across the track. So, again you can change the view angle along and across the track, and it can collect the data up to 35 degrees. So, it can cover very quickly the data. It allows side by side, fore and aft stereoscopic images, forward direction and the backward direction. So, at another point, if it is looking vertically down, the swath would be 11 kilometer. So, one image will cover 11 kilometer by 11 kilometer area. So, but if we want a small strip, if say let us say our area of study is going along a corridor, we can actually order in that particular strip, and the mosaics can be created by the supplying agency, and the data could be placed to you. This is also employing a linear array scanner device to scan the whole of the earth. So, it is providing us data in panchromatic band, and this panchromatic band was from 0.5 to 0.9 micrometer, slightly bigger range, but the data was available at 1 meter resolution. So, in 1999 when this satellite was launched, there was no other satellite data which was available to us at 1 meter resolution. So, that is why this data become very popular, because lot of mapping work or lot of information which was not available from the earlier data was we were able to see from this. Then multispectral band also it has which was providing the data in four spectral bands at 4 meter resolution. So, we are getting 5 images from Iconos data, 4 multispectral images at 4 meter resolution approximately, and one is panchromatic at 1 meter resolution, and these multispectral bands were again within the visible part of the spectrum, like blue, green, red and near infrared band. So, these were the 4 bands available, so that we could create the color composite, we can see the area into color and try to analyze that particular area into color. Now, if you look at the radiometric resolution also becomes much better for this 11 bit, 2 to the power 11. So, that means there were altogether 2048 gray levels present. So, as you know from your background knowledge, more the number of gray levels, better is the image, more clarity is in the image, more number of features one can identify. So, its radiometric resolution as compared to the previous data from the sensor was also higher. So, this data was preferred by different user. If we look at the further characteristics of the data, the Iconos data, so this has a off-Nader viewing capability. So one can, off-Nader viewing capability means that one can see the stereo mode. So stereo mode was available, but one has to make the order prior, so that when the satellite is moving over that particular area, that area could be imaged in the stereo mode. So your requirement has to be placed with the agency prior. It was covering approximately 150,000 square kilometer per day and providing the data in panchromatic as well as in multispectral band. This is the panchromatic data at 1 meter resolution data. This is black and white, is covering the part of the Rome area. So if we look at this particular image, now we can identify even the number of vehicles which are moving on the road at any given instant. So not only the width of the road, not only the dimension of the intersection of the road or the buildings or the streets, but the number of vehicles also. Now, people have identified even done the classification of the vehicles into the trucks and the cars, or the long vehicle or the normal vehicle, short vehicle, something like that. So these images are very useful for carrying out the utility mapping. So then you can identify various features on the ground and prepare various thematic maps. You can also create topographical maps. So this is the Iconos data at 1 meter resolution of Dubai area. So one can see this very important building there and also different features all along the sea area. So this is sea water here, this is all sea water, and then one can see along the coastal region all the setup which is very clearly seen from this data, Iconos data. So people have used this Iconos data to create very large scale kind of a maps at 1:5000 scale. And normally in engineering planning, engineering design purpose, we require 1:5000, 1:4000 scale maps, and these data have been successfully used to create such maps. So this is again a panchromatic data at 1 meter resolution, and this is multispectral data at 4 meter resolution. So now the resolution is different. So amount of information which we can extract from these two data, which is a part of the Columbia region taken in 2000. So amount of information content may also differ, because here we have the information which varies with respect to the wavelength region. Here we have better and better pixel size. So why not fuse them together? Why not merge these two together and take the characteristics of both the data and have a new fused product, so that we can get the better details. So I will explain that part also. The next satellite is a QuickBird satellite. So bird is flying up in the sky, so name is derived from there. QuickBird, it was launched in the year 2000, okay, but it was quickly lost due to the launch vehicle failure. Then QuickBird 2 was launched. So QuickBird 2 was launched in October 2001 at a lower altitude. So altitude was now 470 kilometer from the equator. So it had 4 multispectral bands, blue, green, red and near infrared band at a 2.4 meter resolution. So earlier it was 4 meter resolution from Iconos data, but from QuickBird now we have 2.4 meter resolution, and panchromatic data also was 0.61 meter precisely. Earlier it was 1 meter data. So we had a better and better resolution. That means more and more clarity, more and more identification of those smaller objects. So you can see the QuickBird 2 image of the Rome area, which is shown in the color here also. So one can carry out all that urban mapping with the help of this image. These are some of the specifications of the QuickBird data. So here we can see from this slide that it has 61 centimeter resolution in panchromatic mode, 2.44 meter in multispectral mode, and radiometric resolution was 11 bit. So these are, and there are some of another capabilities similar to the previous one. The swath at the Nadar was 16.5 kilometer, and it was making 14 orbits per day satellite. So this was also similar to the earlier satellite, but with a better resolution capability. So if we see the capability 30° of another angle, just so that one can actually have the larger area, 100,000 square kilometer area was covered in one day. It has a panchromatic band and it has a multispectral band. So on the satellite image, if we see how much is the area covered by QuickBird, which is shown by a yellow box here, the area covered by the Iconos and area covered by the aerial photography is shown. So these are the aerial photography is covering a very tiny area, very small area. So one can see that probably sometimes we feel that much better, it is much better than the aerial photography, the amount of information content available and area covered is much larger than the aerial photograph. So this is the QuickBird panchromatic image at 0.6 meter resolution. So this is more or less, I am showing you the forested area, lot of trees are there, and then there are some road features, some riverine features are present in the area. This is panchromatic black and white data, but the same area we can show in the color and then create a pen sharpened image. What is the meaning of that pen sharpened image? Meaning of the pen sharpened image is that there are many high resolution or very high resolution satellites. They are providing us data in panchromatic band. They are providing us data in the multispectral band. So panchromatic band resolution is much better, whereas the spectral characteristics we take from the multispectral data. So we take the best from the multispectral data, which is the variation in the reflectance with respect to the wavelength region and the spatial resolution, the pixel size characteristics we derive from the pen data, fuse them together and we create a pen sharpened image. So this is a pen sharpened image at 0.6 meter resolution. So it is a now multispectral image, but having a better resolution, 0.6 meter resolution, and it is panchromatic data has been merged. So this kind of technique where we are using the pen sharpened image have been found to be much better, because the details come out very clearly now from this kind of data, and one can carry out the mapping. From this we can identify the other vegetation with the forested area, which is pink shade shown in the middle of this particular scene. So you can, if you compare the two together, panchromatic data and pen sharpened image. So naturally you cannot probably identify many features clearly from the panchromatic data in spite of high resolution, in spite of very high resolution, because the spectral characteristics is missing. So we have both the characteristics in the sharpened image. So we prefer this kind of a data. Then next in this series is OrbView satellite. Old name was Microlab 1. So OrbView, orb word is taken from the orbit. So when the satellite is moving in the orbit, it is viewing downward. So OrbView word is taken from there. It has two sensor. One is OTD, which is called optical transient detector, and another was MET, GPS MET. MET word is taken from the word meteorology. So it was a atmospheric measurement system. So this particular satellite was giving us the data which is shown actually here. on this side the black and white data, quite detailed data we are getting again to carry out very good mapping. So, OrbView 2 was launched in 1997, again sun synchronous polar orbit, lower altitude which was 705 kilometer. The next one, OrbView 3, was launched in 2003 after a gap of 6 years. It had 1 meter panchromatic data and 4 meter multispectral data in blue, green, red and infrared band. So, height was of this was lowered down to 470 kilometer from the equator, and it has a viewing angle of 45 degree, and also the swath width was 8 kilometer. So, one scene was covering 8 kilometer by 8 kilometer area. Radiometric resolution was same as earlier satellite, 11-bit radiometric resolution. So, OrbView 4, which was launched in 2001, was not as successful. It was a launch failure. It had a similar kind of a panchromatic and multispectral data characteristic. So, one can see the OrbView image, panchromatic image of the area where vegetation cover is shown on the top corner, and then we can see the road network pattern and the urban area very clearly from this kind of a data. The next in the series was the WorldView satellites. So, WorldView, viewing the whole world from the top, taken from their name. So, this was launched 18 September 2007, WorldView 1 was launched, and altitude was lower, 496 kilometer from the equator, and it was also capable of collecting the data per day about 750,000 kilometers square data. So, huge data. Now, you can see this data at 0.5 meter spatial resolution multispectral data of Burma region. So, one can see the structure in the center, you can feel even the height of that, and buildings and other features, open land, road, street network, they are all very clear. So, one can carry out various kinds of thematic mapping from this data, extract lot of information without visiting the field, going to the field. So, if we look at the background of this now WorldView data, WorldView 2 was launched in 2009, and it was providing sub-meter resolution. So, resolution became better and better to us, and it was very first high resolution satellite which was offering the data in 8 multispectral bands. So, we are getting the 8 images with greater accuracy and having the stereo capability. So, this was the first of its own kind. Then the next in the series was WorldView 3, which was launched in 2014, again in the polar orbit. Resolution becomes further better, unbelievable, 31 centimeter panchromatic band, black and white. So, pixel size 31 centimeter. So, any object which is 31 centimeter by 31 centimeter could be seen very clearly, and 1.24 meter resolution was available in multispectral mode. Then there were shortwave infrared band which was providing us 3.7 meter resolution and 30 meter resolution in KVS. Then after that the WorldView 4, which was earlier known as GOI2, it was launched in 2016. So, it offers the highest resolution imagery of the earth available for civilian as well as the military application. So, we can see from these high resolution satellites that we have the data which is available to us now at 31 centimeter resolution. So, we can probably cut down our lot of field work whenever it comes to the mapping part of that. Let us see further feature of the WorldView 1, 30 degree of nadir angle. So, it will provide us the stereo images, very useful for creation of very high resolution DM or contour interval at a shorter interval. So, it had a panchromatic data only, there was no multispectral, but When the WorldView 2 was launched, it was had a panchromatic data, multispectral, and there were 4 additional bands. So, we are getting 8 bands data in multispectral mode. It also has the stereo capability because 30° of another angle was there. Very large area was covered in one single day. Let us see WorldView 3 data. So, WorldView 3 also had panchromatic, multispectral and 4 additional bands plus a shortwave infrared band, very useful if you have to carry out a crop disease kind of a study. So, area covered was 680,000 square kilometer per day. It also has a similarly of radar viewing capability, so that one can see the stereo model. So, all these satellites have given us the additional feature of viewing the area in third dimension using the stereo capability of that. WorldView 4, it has a panchromatic band, multispectral band, and then it was also available in data was available in stereo mode because it has a similar off another angle capability. So, if we look at the WorldView 3 data at 31 centimeter resolution. So, if you blow it up further, probably you can get much more detailed information, but what I wanted to show you is that you can see a pool here, okay, a swimming pool kind of a thing, very clearly seen with the color of the water. You can feel the height of the buildings also because of the relief which is present here due to the height of the structure. But what is important to note down here is earlier we were not able to identify those small features like cars, you know, the all by the roadside the cars are parked, and these can be located very easily with the help of these satellite images. Now, there are studies available where people have further classified the cars into different categories. You know, they have tried to even identify the make of the car also, which company's car is this, looking at the size and looking at the shape also. So, it was possible to carry out those detailed investigation with the help of such 31 centimeter resolution data which was not available. But remember one thing, that is the cost associated with. Higher the resolution, I mean you go for 31 centimeter resolution data, higher will be the cost of the data. So, we have to see that there is a direct relationship between the two. If you want to procure very high resolution data for our study area, you have to shell out a lot of money in order to procure those data. The next is GOI data. GOI has a panchromatic band, multispectral band, and again the data was available into the stereo model. Geo means earth. So, you are seeing through the eye for the whole earth. So, that is the name which has been taken from there, GOI. This is again a commercially available data. Pleiades is another, again it is a series 1A and 1B, they are very high resolution twin satellites. So, this is again first time this kind of experiment has been done, and they are offering us 0.5 meter resolution products. So, again sub-meter products they are offering us, and this constellation, you know, the twin satellite constellation has been designed to daily revisit anywhere on the earth with stereo and tri-stereo capability. So, that is the unique feature that if you want to study a particular area every day, and this happens sometimes when there is a emergent situation like a disaster, some disaster take place, flood take place or the earthquake take place, and we will like to monitor the area every day, or there is a forest fire, we will like to monitor the area every day, so that some precautionary measures could be taken, some better planning could be done to save the life of the people, and future planning could be done in that area. So, we may require quite frequent images for that area, and this satellite Pleiades can give us the very high. The same area which I showed, this swimming pool area, this is at 50 centimeter resolution. So, these are those pool areas, and again you can see the cars which are parked all along the side of the road, and then the height of the building. You can see the shadow now this time, because the sun angle is this side is the sun angle, and it is casting the shadow. So, there are so much of shadow now in this area that probably below the shadow it becomes difficult to identify the features. So, there are techniques by which we can remove this shadow and can identify, or using the shadow as the positive characteristics we can determine the height of the structure and height of the buildings. So, these images are very useful. So, if we have a quick look on the what are the very high resolution satellite images available to us, this is a list here. We have I have not covered many of these, but they are listed over here. We have very large number of satellites which have been launched by different organizations and different countries with resolution which is ranging from 3 meter to 2 meter to 70 centimeter to 30 centimeter. Like ComSat is providing us the data at 55 centimeter in panchromatic and 70 centimeter in the color mode. So, likewise the list is very long here, including the Indian remote sensing Cartosat data which is available to us in 1 meter panchromatic mode. So, we can make use of these high resolution satellite data and create maps at 5000 scale, maps at 10,000 scale very easily. Like this example shows the satellite data which is available to us from Iconos at 1 meter, QuickBird at 0.62 meter, and OrbView at 1 meter resolution. So, this is a spatial resolution which is written over here. Same area has been covered by 3 different satellites, and you can probably see some of the planned building in the top area. You can see some well defined kind of a rows and lines, but unplanned area also one can see haphazard growth. So, the old planning was done in the lower part of the area. So, a planned city and unplanned city we can actually carry out very easily from this kind of a data. Now, if we have to map individual buildings, like we have to suppose create a map which is used for collecting the revenue from the constructed area. For example, for the municipality, okay, who are collecting the revenue on the constructed area. So, these satellite images have been used for that purpose, and here each and every building has been mapped. All the red boxes which you see here, they are the polygons which have been manually digitized now with the help of this, but there are techniques which can extract directly this kind of a feature, building extraction from the high resolution satellite image. So, we can have a land parcel mapping, and once we know that which are the pervious area and which are the impervious area, we can calculate the impervious surface, because this kind of a study is also very useful whenever there is a rainfall in the area where the entire water would flow, whether it will be flooded in that region or the water will percolate to the ground. So, we have to say, let us say, find out the pervious area and impervious area in the region. Very clearly we can identify. Vegetation, for vegetation study we can create vegetation index, like normalized vegetation index or green vegetation index. So, different vegetation index, because of the multispectral bands which are available, we can create different vegetation index. Higher the value here, higher is the vegetation cover in that particular region. Then we can also correlate all these things with the stormwater runoff from the land parcel. So, we can see which are the land parcels unvegetated, which are the land parcels where impervious land is there. So, all that information when we have, we can carry out the stormwater runoff modeling as has been shown here with the green color. So, our very high resolution satellite images, they usually cover very less area per pixel, but they are offering us very good advantage of higher spatial resolution, which can provide us very accurate very valuable and timely information, whether we want to carry out any change analysis, or we want to extract one time information, or we want to use for some modeling purpose or some natural disaster emergency response systems. They are found to be very useful. We can actually, the level of details, the level of information which we can derive from this particular data is very useful to develop the algorithm, to apply the algorithm, to monitor the changes, to detect the objects automatically, or to study the trend, or to track the human activities. So, very high resolution images have been used by the administrators for different purpose, and these images have very good applications, very good utility for military as well as the civilian application. So, if we talk about the scales, at what scales I can carry out the mapping very successfully, if the resolution from this high resolution images, we are taking 1 meter pixel resolution, we can carry out 10,000 scale mapping, or if we have 0.5 to 0.6 meter resolution data, we can very easily carry out 1:5,000 scale mapping, topographical mapping, not just the two-dimensional mapping, but we can draw the contours, we can get the elevation data, and there are very successful examples available in the literature where these data have played very important role to create topographical maps at that particular scale. So, this is all. Thank you very much.